Hello viewers, Mr. Nyati here, your presenter. I'm back again. A continuation of Physics 2024 grade 12 internal past paper, that is science paper 1. So we continue with question B2 in section B. And the first question, in question A, of course, as usual, like the video, share, hit on the bell button, and leave a comment on the comment section. The question says, state Newton's second law of motion. Now, you need to understand that Newton, at least in this syllabus, the 5124 Science Paper 1 or Science or Physics 5124 syllabus, Newton is presented to have 3 laws of motion, and you need to know each one of them. So there is the first law, there is the second law, and the third law. So I must emphasize that you need to know the 3 of them, okay? So now, Newton's first law of motion, what does it state? Well, Newton's first law of motion states that an object at rest will continue or will remain at rest, okay? And an object in motion will continue to move with constant velocity unless acted upon by an external force. So this law is sometimes is also called the law of inertia. Law of inertia. Law of inertia. Okay. And what is inertia? Well, inertia is basically the resistance of a body to change in motion. I'll give you an example. Let's say you are on a bus, on a car, okay, moving, and as you are moving, the car begins to accelerate to some reasonable speed or velocity, and then let's say the driver realizes that there is a sign for animals, a road sign for animals, and he probably sees animals at, let's say, 100 meters away. Now, what the driver has to do there is basically to follow the normal instincts of a human being, which is to apply the emergency brakes. And as the driver does so, you will realize that if you are not putting on the seat belt, you've not buckled up, you will be thrusted in front, okay, of the vehicle, or you'll be thrown by force to the front part of the vehicle. Now, why is it so? This is because of the fact that your body is resisting to change in motion, okay? At that point, when the body is just relaxing, being driven by a car, in that state, the body is somehow at rest. But when the brakes have been immediately applied, the body will not accept to move at the pace of the car, okay? The body will be forced to move at the initial velocity at which the car was moving. So that itself is what we call inertia. So the body will do some resistance in changing in motion, okay? Now, what you need to also understand is that the bigger the inertia, the bigger the body or the bigger the mass of a body, the bigger the inertia, okay? While the smaller the size or the mass of a body, the smaller the inertia. And that is why when you are a person, well, I've lacked better terms to describe this. When you are a person who is physically blessed, who is fat, you will find that it will take time for you to run in a zigzag manner. You may not even manage, okay? Because your body is resisting to change in the direction of motion, okay? That itself is inertia. And because your body has a bigger mass, it will resist to easily change in the direction of motion. But if you are a person who has a small body, it will be easy for you to do what? To meander through in a zigzag manner as you run. And that is why when you are a footballer, it is advised to make sure that you work on your physique, on your appearance, so that you don't have a lot of challenges when it comes to dodging when playing football. So that is it. So the Newton's first law of motion says that an object at rest will remain at rest, and an object in motion will continue to move with constant velocity unless acted upon by an external force. So you can leave this thing here as long as there is no force that is applied on it. We will find this after 30 years, provided there is nothing that has been applied this in terms of force. That's what this law states. But if we apply force to this, of course it is going to move. As you have seen, it has moved. Okay. Then we proceed to Newton's second law of motion. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Okay, so what does this mean? It means that the acceleration of an object is directly proportional, meaning that when the force increases, you expect also acceleration to do what? To increase. However, if the acceleration has to increase, then the mass must be a smaller one, okay? The mass must not be very big for acceleration to find it difficulty to drive that mass. That's what it means. So mathematically speaking, what we are saying here is that the acceleration of the body is directly proportional to force and inversely proportional to mass. So when you go the mathematical way, you combine these expressions, you're going to have acceleration being equal to force over mass. Now, at this point, as you all know, we have this formula in physics. You have to make F the subject of the formula. So we are going to say force is equal to mass times acceleration. This is the formula for force. This is where we get the formula for force from Newton's second law of motion. As in this force is equal to mass times acceleration. Of course, in physics, we are not limited to this formula for force. There are so many, okay, out of different parameters. So now this is what it means. So we go to Newton's third law of motion. For every action, there is an equal and opposite reaction. That is very true. For every action, there is an equal and opposite reaction. So I thought I should actually highlight these three laws of motion. But the question is basically demanding for Newton's second law of motion. So which one are we going to go for? This one. So the answer for question BA, we are going to say this is BA. Okay? Newton's second law of motion. So that is the answer to the first question. Then we move forward. A block of mass, 500 grams, is pulled from rest on a horizontal frictionless bench by a horizontal force F and attains a velocity of 8 meters per second in 2 seconds. Now, before we go to the question, let's understand what this is. We are being told that there is a block of mass. So let's come up with the data. Okay, this is question B. Question B. Let's come up with the data. What data can we gather from that? So we are told that there is a body of mass 500 grams. Mass is equal to 500 grams. Now remember, mass must always be in kgs. So we must make sure that for us to find the kgs, we divide that by 1000, which is going to give us 0.5 kilograms. Okay, that's what we are gathering from the question. We proceed. What else can we gather? We are told that is pulled from rest. So, because there is rest, we need to come up with something here. And when we proceed reading, we find that there is velocity. So rest basically tells us that the body had an initial velocity of 0 because it was resting. So there is an initial velocity of 0 meter per second. What else we have? The final velocity, at least we are told in the question that of 8 meter per second. 8 meter per second. And then we have also time of 2 seconds. We have time of 2 seconds. So now what is the question demanding in Roman numeral 1? Uniform acceleration of the block. So acceleration of the block. Now, so this is how you basically approach questions in physics, because the data helps you to find what is missing, and it also helps you which route you are going to use in achieving the answer, okay, or in arriving at the answer. Now you go to the formula, because we are looking at question question B1, the uniform acceleration of the block. So acceleration, we know that acceleration is equal to V minus U over T. Of course, there is another formula which is V is equal to U plus AT. But this one is quite appropriate and straight to the point. So we're going to say, what is V? We have 8 meter per second minus 0 meter per second over time taken 2 seconds. When you do your math, you are going to find that the answer is 4 meter per second squared, because acceleration is measured in meter per second squared. That's the answer. This one was the Roman numeral 1. We move on to Roman numeral 2. Calculate the value of the force, the F. That is why whenever you see Newton's second law of motion, remember I emphasize that this is why we get the formula for force. So all these have followed behind this, because everything that we are doing here, this one is more like the motherboard of all these that we are doing here. So that's why you have to be very careful, and you also have to know where is this all coming from. That is very important in sorting out such questions. So we calculate the value of F. Now, we know that for B2, from the data that we gathered here, the formula for F is force is equal to mass times acceleration. What is our mass? It is 0.5 kg multiplied by the acceleration, which we've just calculated, 4 meter per second squared. What is the answer? Well, the answer must be, if we say this one, okay, the answer must be 2.0 newtons. Okay, this must be the answer, because we are saying that half multiplied by 4. This is the answer. So this is how you basically solve these questions. I hope this was helpful. Thank you. Bye-bye.